Hi, we are going to now learn about distance on a coordinate plane. And, we've done in the past when we have, uh, distance in either a straight line, whether it's horizontally or vertically, all that we're doing, if it's in the same quadrant, we are subtracting the absolute values between the two ordered pairs. If it's in different quadrants, we add the absolute values of the distance between the two ordered pairs. So that is a sixth grade standard, which we have already covered. For math team competitions, you will probably be given the distance which is not in a straight line. Okay, so let's look at this example. We have 5 8 and we have 11 0. Uh, the x or the y are not the same, so we know it's going to be a slant. Okay, so there is a formula that is used for this, and distance on a coordinate plane is equal to square root of x2 minus x1 squared plus y2 minus y1 squared. So when I say, x2 and x1, what that means, so basically the first ordered pair, we have x1 and this is y1. Remember, the first coordinate is always the x coordinate. The second coordinate is always the y coordinate. So, and then this one is your x2 and y2. So we are trying to find the distance between these. Okay, so in order to incorporate this formula, a couple of things that we can look at. This is this one over here. This is the horizontal distance. This is the horizontal distance, and this is the vertical distance. This is the vertical distance. Okay, so when I say horizontal, it means this way, and vertical means this way. All right, now in order to solve this, all I'm going to do is I am going to incorporate the values that I have in the ordered pairs into this. Okay, so let me go ahead and do it over here. Okay, so using this formula, I am going to do distance is equal to, all right, we have x2 over there, which I know x2 over there is given as 11 minus x1, which is 5 squared, plus I have y2 given as 0 minus y1 is 8 and squared. All right, so we write that out, and then I'm just substituting, and then now I'm going to solve based on order of operations. Everything within the parentheses has to be solved first. So 11 minus 5, I get 6 squared, plus 0 minus 8 gives me negative 8 squared. Okay, and then 6 squared is going to be 36 plus 8 squared. Negative 8 times negative 8 gives me positive. So here we get 64. And then 36 plus 64, I get square root of 6. This is 100. And so therefore, what times itself is going to give me 100. So that's what square root means. And I know that 10 times 10 gives me 100. So therefore, my distance between these points is 10 units. All right. And so that's how we calculate distance. Okay. Now, I'm going to give you another example. So let me move this. And let's say my next ordered pair, I'm going to give you another ordered pair. Let's say I have 4 3 and 0 0. All right. So if I have, again, we know this is x1, this is y1, this is x2, this is y2. So we are going to use the same formula where distance is equal to square root of x2 minus x1. So 0 minus 4 squared plus y2 minus y1, which is 0 minus 3 squared. Okay, so when I do this, I get square root of negative 4 squared plus negative 3 squared. And that tells me negative 4 times negative 4 is going to give me 16, plus negative 3 times negative 3 is going to give me 9. And therefore 16 plus 9 is square root of 25. So I have to think what times itself is going to give me 25, because that's what square root is. And I know that 5 times 5 is 25. So therefore my answer over here is 5 units. And that is the distance between these. All right, so far I'm showing you the ones where we have perfect squares. So let me show you an example where it may not be a perfect square. I'm trying to get that glare out of the board. Okay, all right, so let's do a problem which is not exactly a perfect square, and then you can see how we factor out in the answer part. Okay, so let me give you a point. Let me go ahead and erase this. So let me give you the ordered pair of, let's say, 3, 2, 3, 2, and 7, 8. 3, 2, and 7, 8. Okay. So again, we are going to um, follow the exact same formula where here we have x1, y1, x2, and y2. All right. So D is equal to x2 minus x1. Okay. So 7 minus 3 squared plus y2 is 8 minus y1, which is 2 squared. Okay. So I get 7 minus 3, it gives me 4 squared plus 8 minus 2, which is 6 squared. 4 squared plus 6 squared. And that gives me 4 times 4 is 16, plus 6 times 6 is 36. Okay, so if I do 16 plus 36, I'm going to end up with square root of 52. All right, now what I always suggest, of course, you've got to factor this out. And very often what I do is I just take this number. I'm going to do it over here. I take the square root of 52. And then I start doing the prime factorization to tell me from where can I get a perfect square on this, okay? So if I start doing this, I can, see where am I going to get a perfect square to break it apart further. So I know this is an even number, so it's 2 times 26. This is prime, and then I go here and I do 2 times 13. Now these are all prime. Okay, so I know that 2 times 2 is 4. So I can always break this apart into square root of 4, right, times square root of 13. Because I know that square root of 4 is going to give me 2. Okay, because 2 times 2 gives me 4. And so once I solve this, I can remove the square root part because square root of 4 is 2, root 13, and I can write the answer like this. So this would be my final answer in this aspect. So you do have questions like this where you will have to factor it out if it is not a perfect square like the two examples that we solved before this, okay? Let's go ahead and I can solve another one in which we have to factor out. So let me erase this one. And let's say my ordered pairs now are 2, 1, and I have -3, -4, -3, -4. Okay, once again, x1, y1, x2, y2. All right, so using the formula, d is equal to square root of x2, which is -3 minus 2 squared, plus y2 is -4 minus 1 squared. All right. So now when we have integers which are the same sign, we basically add them. So it's like saying I have 3 negatives and I have 2 more negatives. So that gives me a total of -5. Okay. So this is going to be -5 squared plus, same thing here. You have 4 negatives and then you have another 1 negative. So total amount is -5 squared. Okay, so negative times negative becomes positive. So if I say -5 times -5, because it's -5 squared, I'm going to get positive 25. Okay, so this is 25 plus -5 times -5 also gives me my 25. Okay, and so this is, when I add this up, 25 plus 25, I get 50. So in order to factor out 50, I'm going to just again do the prime factorization. All right, and but actually just looking at it, but still I can just see that what those numbers will be, but I'm just going to show it to you anyways. All right. So if I have a square root of 50, as I said, go ahead and do the prime factorization. I can get 5 times 10. This is prime. And then I get 5 times 2, which is going to give me this part. So now these are the prime numbers. I can see that 5 times 5 is 25. And 25 times 2 is going to give me 50. So therefore, I'm going to break this apart into 25, because I can do square root of 25 to get 5, times root 2. And then after that, all I do is I remove the square root and I get, because 5 times 5 or 5 squared is 25, right? So square root of 25 is going to give me 5 root 2. And so here is my final answer where the distance is concerned. So very easy. All you're doing is following this formula and distance on a coordinate plane. And that is going to be square root of x2 minus x1 plus y2 minus y1. Have a great day.